Hey there, how's it going? Thanks for joining me today. Whether you're relaxing at home, on your commute, or winding down for the evening, I'm really glad you're here. Now, I want you to do something for me. Tonight, when you look up at the sky, I want you to imagine something absolutely mind-blowing. Picture this. 4 billion years from now, there's a galaxy filling half our entire sky. Not just a tiny dot or a faint smudge, but a massive, swirling collection of 1 trillion stars stretching from horizon to horizon. That galaxy is Andromeda, and right now, at this very moment, it's racing toward us at 250,000 miles per hour. But here's what's wild about this story. What if I told you that cosmic collision could begin right now? Not 4 billion years from now, but today. Imagine that cosmic clock jumping forward, and suddenly we're witnessing the most spectacular show the universe has to offer. 2 island universes, each containing hundreds of billions of stars, beginning their ancient dance right outside your window. Think about that for a second. The Milky Way, our home galaxy with its 400 billion suns, meeting Andromeda, a trillion-star titan that's twice our size. These aren't just collections of stars we're talking about. These are entire universes of worlds, each one potentially harboring life, stories, civilizations we can't even imagine. Now, I know what you're thinking. This sounds terrifying, right? 2 massive galaxies crashing into each other at 250,000 miles per hour? You're probably picturing some cosmic demolition derby, stars exploding left and right, planets getting flung into the void. But here's the thing that's going to blow your mind. That's not what happens at all. You see, galactic collisions aren't the violent crashes they sound like. Picture this instead. 2 ghosts passing through each other, each made of glittering light separated by unfathomable darkness. I want you to really understand just how much empty space we're talking about here. If our sun were a grain of sand sitting in New York City, the nearest star would be another grain of sand in Los Angeles. That's how much emptiness exists between stars. So even as these 2 massive galaxies interpenetrate, even as they pass through each other over millions of years, the chance of any 2 stars actually colliding is less than 1 in 1 trillion trillion. Let me say that again. 1 in 1 trillion trillion. You're more likely to win the lottery every day for 1 million years straight than to see 2 stars crash into each other during this collision. But here's where it gets really fascinating. Even though nothing crashes, everything changes. If this collision began today, right now, sensitive instruments around the world would start detecting the first gravitational whispers. Andromeda's invisible hand is already reaching across 2.5 million light-years of void, gently tugging at our galaxy's edge. And I mean gently. We're talking about forces so subtle that it takes the most sophisticated equipment on Earth to measure them. But those stars that have been circling peacefully for billions of years, they're about to feel new forces. Stars that have never known anything but the gentle gravitational pull of our own galaxy's center are suddenly experiencing the influence of an entirely different cosmic giant. It's like they're hearing a new song for the first time, and they can't help but start dancing to it. The cosmic dance has begun, and over the next 7 billion years, these 2 magnificent spirals will merge into something entirely new. But long before that final union, OPS, long before the galaxies become one, Earth's sky transforms into the greatest show in the universe. Picture standing outside on a clear night, maybe 1 million years from now, where once Andromeda appeared as that faint smudge you could barely see without a telescope, it now dominates the northern sky. It's no longer just a distant neighbor. It's a ghostly spiral growing more magnificent with each passing generation. You can see its spiral arms, its glowing core, maybe even some of its individual star clusters, but that's just the beginning. As tidal forces, ocean forces, not the gentle tides of Earth's oceans, but gravitational forces that reshape entire galaxies, begin their work, something magical happens. Stars at the edges of both galaxies feel the pull more strongly than those near the center. This creates streams of stars that arc through space like cosmic ribbons, painting the darkness with trails of light that stretch across the entire sky. And here's what's absolutely incredible about all of this. While this cosmic transformation is happening, while two galaxies are literally passing through each other, Earth just keeps on spinning. The sun keeps shining. The seasons keep changing. Life goes on. You might wonder how that's possible. Well, it comes back to those incredible distances I mentioned. Even during the most chaotic phases of the collision, no star comes close enough to disrupt our solar system's delicate gravitational balance. We're like passengers on a ship during a storm. We might see the lightning and hear the thunder, but we're perfectly safe inside our little cosmic bubble. But what we get to see, oh, what we get to see is beyond imagination. As gas clouds from both galaxies collide and compress, star formation explodes across the merging system. The collision triggers the birth of millions of new stars, creating stellar nurseries that glow brilliant blue with young, hot suns. From Earth, the night sky becomes a light show that would make the northern lights look like a candle flame. Vast star-forming regions paint the darkness with glowing nebulae in every color you can imagine. Brilliant reds from hydrogen, deep blues from hot young stars, greens and purples from exotic gases we rarely see. The merger doesn't destroy. It creates on a scale that staggers the Phi's mind. Now, I want you to think about something that might seem strange at first. We talk about this collision like it's something that's going to happen in the future, but in a very real sense, it's already begun. Right now, at this very moment, Andromeda and the Milky Way are locked in a gravitational embrace that spans millions of light years. The dance started long ago. We're just now becoming aware that we're part of it. Dark matter halos, array, the mysterious scaffolding that makes up 85% of each galaxy's mass, are already making first contact. Imagine two vast soap bubbles beginning to merge, except these bubbles are millions of light years across and completely invisible to our eyes. Only their gravitational effects reveal the drama that's unfolding. This is the story we're going to explore together, not just the collision itself, but what it means for Earth, for humanity, for the future of everything we know. We're going to discover how scientists figured out this cosmic destiny, what happens to planets like ours during galactic mergers, and why this collision might be the greatest opportunity in human history. But most importantly, we're going to understand why galactic collisions aren't cosmic catastrophes. AU9. They're the universe's way of creating something new and magnificent. They're how the cosmos builds itself, one spectacular merger at a time. So as you drift off to sleep tonight, remember this. Somewhere out there in the darkness, Andromeda is racing toward us at 250,000 miles per hour. But it's not coming to destroy us. It's coming to dance with us, to create something beautiful and new, to write the next chapter in the greatest story ever told, the story of how the universe builds itself through collision, creativity, and cosmic wonder. And we, made of star stuff mixed by ancient galactic mergers, are here to witness and understand this magnificent process. We're not just observers of this cosmic dance. We're part of it, products of billions of years of cosmic creativity that continues tonight, tomorrow, and for trillions of years to come. The collision isn't coming. We're already part of it. Now that we've set the stage for the most spectacular show in the universe, let me walk you through exactly how this cosmic dance unfolds. Because what's about to happen over the next 7 billion years isn't just a simple crash. It's an intricate choreography that makes a ballet look like child's play. Let's start at the very beginning, year 1 of the collision. Now, if you were standing outside on that first night, looking up at the stars, you wouldn't see anything different at all. The constellations would look exactly the same. Andromeda would still be that faint smudge you need dark skies to spot. But here's what's wild. deep in space, the invisible transformation has already begun. Picture this: dark matter halos, that mysterious scaffolding that makes up 85% of each galaxy's mass, are making first contact. I want you to imagine two vast soap bubbles beginning to merge, except these bubbles are millions of light years across and completely invisible to our eyes. We can't see them, we can't touch them, but we know they're there because of their gravitational effects. And right now, in year one, these invisible giants are starting to feel each other's pull. Think about that for a second. While you're going about your daily life, while civilizations rise and fall, while species evolve and go extinct, this titanic invisible dance is beginning. The universe is reshaping itself on a scale so vast that our entire recorded history is less than a blink of an eye in comparison. Fast forward to year 1 billion. Now we're talking about a timescale that's hard to wrap your head around. 1 billion years ago on Earth, life was just beginning to experiment with multicellular organisms. There were no plants on land, no animals with backbones, no eyes that could see. But if humans had existed back then and looked up at the night sky, they would have noticed something remarkable happening. Andromeda starts growing visibly larger each century. Where once it appeared as that barely visible smudge, it now begins to dominate the northern sky. Picture generations of astronomers, each one noticing that this ghostly spiral has grown just a little bit bigger than what their grandparents observed. It's becoming more magnificent with each passing era, its spiral arms becoming clearer, its central bulge more prominent. But the real drama is happening at the edges. Tidal forces. I am not talking about the gentle tides that wash Earth's beaches, but gravitational forces that can reshape entire galaxies begin their work. You see, stars at the edges of both galaxies feel this pull more strongly than those near the center. It's like being in a room where someone is gently pulling a tablecloth. The items at the edges move first and move the most. This creates something absolutely breathtaking. Streams of stars that arc through space like cosmic ribbons. Imagine looking up and seeing rivers of light flowing across the sky, each river made up of millions of stars being pulled into new orbital patterns. These stellar streams stretch for hundreds of thousands of light years, painting the darkness with trails of starlight that would make the Milky Way's band across our sky look ordinary by comparison. Now, here comes the really exciting part. Year 2 billion brings the first close passage. And when I say close in cosmic terms, we're still talking about distances that would take light years to cross. But for galaxies, this is intimate contact. Andromeda swoops past, and for the first time, it truly fills our entire sky. Imagine stepping outside and seeing not just a galaxy overhead, but spiral arms stretching from horizon to horizon. The core of Andromeda blazes like a second sun, but one made of billions of stars instead of nuclear fusion. You can see individual star-forming regions glowing like cosmic cities across its arms. The detail is incredible. It's like having a front-row seat to the architecture of the universe. For a brief cosmic moment, and I say brief, but we're talking about 100 million years here, the two galaxies perform a celestial ballet. Their spiral arms reach toward each other like cosmic lovers, gravitational forces creating bridges of stars and gas that connect the two systems. It's as if the galaxies are holding hands as they dance past each other. But here's what's fascinating. Andromeda doesn't just fly by and disappear. This isn't a drive-by cosmic encounter. Like a pendulum drawn by gravity, it swings past and then begins its return journey. The gravitational embrace is too strong to break. These two cosmic giants are locked in a dance that can only end in merger. During this first passage, something dramatic happens to the stellar population. Billions of stars are flung into wild new orbits. Some achieve what astronomers call escape velocity, and moving so fast that they break free from both galaxies entirely, destined to wander the intergalactic void forever. These hypervelocity stars become cosmic refugees, carrying with them any planets or moons they might have, sailing through the darkness between galaxy clusters at speeds of up to 1,000 miles per second. Others, including possibly our own Sun, might be thrown into elongated orbits that carry them far from their original galactic homes. Picture our solar system being flung to the outer edges of the galaxy, where the night sky grows darker but paradoxically safer. Or imagine us being captured by Andromeda during the close pass, suddenly finding ourselves citizens of an alien galaxy, watching our birth galaxy recede into the distance. But the most spectacular events are yet to come. The Great Merger reaches its climax around year 4 billion. By now, both galaxies have been thoroughly stirred. Their original spiral structures are completely disrupted, their stars scattered into new patterns that no longer resemble the elegant pinwheels they once were. The galactic cores, each harboring a supermassive black hole, spiral toward each other in what can only be described as a death dance. Our Milky Way's black hole, weighing in at about 4 million times our Sun's mass, meets Andromeda's 100 million solar mass monster. Now, I want you to understand just how massive these objects are. If you could somehow compress the Earth down to the size of a marble, our galaxy's central black hole would still be larger than the Sunday. As these two cosmic behemoths spiral toward each other, they create gravitational waves, actual ripples in the fabric of space-time itself. These waves carry away the orbital energy of the black holes, causing them to spiral inward faster and faster. It's like cosmic friction, except instead of heat, the energy gets radiated away as distortions in space and time. The final merger of these black holes releases more energy than all the stars in both galaxies combined. Think about that. More energy than 1 trillion nuclear furnaces burning for billions of years, all released in a matter of hours. Yet here's what's incredible. This titanic event remains completely invisible to the naked eye. You could be watching from a safe distance and see absolutely nothing. The energy is released as gravitational waves and high-energy particles, detectable only through the subtle warping of space itself. But don't think this cosmic collision is all about destruction. Throughout this entire 7 billion-year dance, something magnificent is happening. As gas clouds from both galaxies collide and compress, star formation explodes across the merging system. A typical spiral galaxy like ours forms about 1 new star per year. During the peak of the collision, that rate skyrockets to hundreds of stars annually. The merging galaxies blaze with stellar nurseries, each one a factory producing new suns. These aren't just any stars. Many of them are more massive than our Sun, burning hotter and brighter, painting the cosmos in brilliant blue light. When these massive stars reach the end of their brief lives, they explode as supernovas, enriching the surrounding space with heavy elements, carbon, oxygen, iron, and all the building blocks necessary for planets and life. The collision acts like a cosmic mixing bowl, stirring these enriched materials throughout the merged galaxy. Regions that could never have formed rocky planets suddenly receive the raw materials they need. What were once stellar deserts become fertile grounds for new solar systems, new worlds, new possibilities for life. By the end of the merger, something entirely new has been born. The two spiral galaxies no longer exist as separate entities. In their place stands Milky, a massive elliptical galaxy that contains all the stars, planets, and possibilities of both its parents, plus billions of new stars born from their cosmic union. But here's what I find most amazing about this entire process. While galaxies are colliding, while black holes are merging, while the very structure of local space is being rewritten, life on planets like Earth continues virtually undisturbed. The distances between stars are so vast that planetary systems sail through this cosmic chaos, like ships in the night, their orbits unchanged, their worlds still spinning peacefully around their suns. It's a perfect example of how the universe operates on multiple scales simultaneously. On the galactic scale, everything is drama and transformation. On the planetary scale, it's just another day in the cosmic neighborhood. The universe has a way of protecting the small and intimate while creating spectacle on the grandest scales imaginable. And this dance we've been describing, it's not unique to the Milky Way and Andromeda. Right now, at this very moment, over 100 similar cosmic ballets are playing out across the observable universe. Each follows the same basic steps, the same gravitational choreography, yet each creates something unique and beautiful. The 7 billion-year dance is really just one movement in a much larger symphony, RFST, the ongoing evolution of the universe through collision, merger, and creation. And we're not just observers of this cosmic ballet, we're participants, products of ancient mergers that gave birth to our galaxy, our solar system, and ultimately, us. Now, let's bring this cosmic story home, literally. Because while we've been talking about trillion-star galaxies and black holes millions of times more massive than our sun, there's one question that's probably been nagging at you. What happens to us? What happens to Earth, to our solar system, to everything we know and love during this galactic collision? If the collision began today, humanity would have millions of years to prepare and observe. And I want you to think about that timeline for a moment. Millions of years, modern humans have only existed for about 300,000 years. Our entire recorded history spans maybe 10,000 years. So, we're talking about a time frame that gives us literally thousands of times longer than all of human civilization to get ready for this cosmic transformation. The first changes would appear subtle, so subtle that you'd need to be an astronomer to notice them. Precise measurements would show minute shifts in stellar positions, tiny changes in the way light from distant stars reaches us. But within 1 million years, still an enormous amount of time, by human standards, the night sky begins its spectacular transformation. Picture this. Andromeda, that faint smudge you can barely see on a clear night, starts growing. Not quickly, not dramatically at first, but persistently, generation after generation. Your great-great-grandchildren might notice it's a bit brighter than the old star charts indicated. Their descendants might comment that it's definitely gotten bigger, and eventually it grows to rival the Milky Way's band across our sky. Imagine looking up and seeing not just one galactic plane overhead, but two. The familiar Milky Way stretching from horizon to horizon, and this alien spiral crossing it at an angle, creating a cosmic cross in the night sky. Two island universes, one familiar and one foreign, painting the darkness with their combined light. But here's where things get really interesting for Earth. As tidal forces strengthen, our cosmic neighborhood transforms dramatically. Our Sun, which currently orbits the galactic center every 225 million years in a stable, nearly circular path, might be flung into a radically different orbit. Now, computer simulations, and we're talking about some of the most sophisticated calculations ever performed, running on supercomputers for months at a time, show 3 possible fates for planets like Earth during galactic collisions. First, and this is the most likely scenario, we get thrown into a longer, more elliptical orbit. Instead of our current nice circular path around the galactic center, we might find ourselves on a cosmic roller coaster. Sometimes we'd be close to the galactic core, where the night sky blazes with the light of billions of stars packed tightly together. Other times, we'd swing out to the galaxy's outer reaches, where the night sky grows darker, but paradoxically safer. Think about what that means for future civilizations on Earth. For millions of years, they'd live in the galactic suburbs, where the sky is dark and quiet, perfect for deep space observation. Then, over the course of hundreds of millions of years, they'd slowly swing back toward the galactic center, watching the sky grow brighter and more spectacular with each generation. It would be like living through cosmic seasons, each one lasting longer than the entire history of complex life on Earth. The second possibility is even more dramatic: complete ejection from the galaxy. Picture our entire solar system being flung out of the merger zone with such velocity that we escape both galaxies entirely, becoming a rogue solar system drifting through intergalactic space. Now, that might sound terrifying, but here's what's amazing. From Earth's perspective, very little would change. The sun would continue shining just as it always has. Earth would keep orbiting at the same distance, experiencing the same seasons and the same day-night cycle. Life would continue exactly as before. The only difference would be the night sky. Instead of the familiar constellations, instead of the Milky Way's bright band, future humans would look up at a completely black sky, punctuated only by distant galaxies. But what a view that would be! Without our own galaxy's dust and stars interfering, astronomers would have an unobstructed view of the entire universe. They could study galaxies billions of light years away with unprecedented clarity. In a sense, ejection from the galaxy would turn Earth into the ultimate astronomical observatory. The third possibility is perhaps the most spectacular of all. Our solar system gets captured by Andromeda during a close pass, switching galactic allegiance entirely. Imagine Earth's astronomers watching their birth galaxy recede into the distance while they explore an entirely new galactic home. Think about what that would mean for human culture, for our sense of identity. For billions of years, humans, if we're still around in recognizable form, would call Andromeda home. They'd map its spiral arms, name its star clusters, explore its planetary systems. The Milky Way would become ancient history, a distant galaxy that their ancestors once called home. But here's what I find most reassuring about all these scenarios. Throughout every single one of them, Earth's immediate environment stays remarkably stable. The distances between stars are so vast that even during the most chaotic collision phases, no star comes close enough to disrupt our solar system's delicate gravitational balance. Let me put this in perspective. The nearest star to our Sun is Proxima Centauri, about 4¼ light years away. During the galactic collision, that distance might change. Maybe Proxima gets flung away. Maybe a different star becomes our nearest neighbor. But for any star to get close enough to gravitationally disrupt Earth's orbit, it would have to come within about 1 light year of our Sunday. The probability of that happening is so small that it's essentially zero. We're talking about trillions of stars passing by each other over millions of years, and the chance of any two coming that close is like randomly throwing marbles in the Pacific Ocean and having two of them collide. It's theoretically possible, but so unlikely that we don't need to worry about it. But the collision doesn't just leave us unharmed. It brings unexpected benefits. As gas clouds from both galaxies collide and compress, star formation explodes across the merging system. From Earth, assuming we maintain our planetary orbit somewhere in the merger zone, the night sky becomes a light show beyond imagination. Picture looking up and seeing vast star-forming regions glowing across the sky. These aren't just distant points of light. They're stellar nurseries the size of entire constellations, blazing with the birth of millions of new stars. The most massive of these newborn stars burn brilliant blue, so hot and bright that they outshine everything else in the sky. These stellar factories paint the darkness with glowing nebulae in every color imaginable. Brilliant reds from hydrogen gas, deep blues from the hottest young stars, greens and purples from exotic elements we rarely see. The entire sky becomes a canvas painted with the colors of creation itself. And here's something that will blow your mind. Many of these new stars will be more metal-rich than our Sunday. In astronomy, metals means any element heavier than hydrogen and helium, things like carbon, oxygen, silicon, iron, all the elements that make rocky planets possible, that make life possible. The collision mixes together gas from both galaxies, creating regions enriched with heavy elements from billions of years of stellar evolution. This means the merger doesn't just create new stars, it creates better conditions for planets and life. Solar systems born during the collision might have access to resources and heavy elements that our own solar system never had. Rocky planets might form more easily, more abundantly, in compositions we've never seen before. Future Earth might find itself in a cosmic neighborhood far richer and more diverse than anything we can imagine today. Instead of being alone in our little corner of space, we might be surrounded by thousands of new planetary systems, each one a potential harbor for life, each one offering unique opportunities for exploration and discovery. The collision turns our cosmic backyard into a cosmic metropolis. And throughout all of this transformation, all of this spectacular change, Earth just keeps spinning. The seasons keep changing. The tides keep flowing. Life continues to evolve, adapt, and flourish. In fact, by the time the collision reaches its peak, life on Earth will have had millions of years to prepare for and adapt to the changing cosmic environment. If humans are still around, and that's a big if over such timescales, we'll have evolved and adapted in ways we can't even imagine. We might have spread to other star systems, other galaxies even. We might have technologies that make the entire collision look like a minor inconvenience. Or we might have evolved into something so different from current humans that the collision becomes an opportunity rather than a challenge. Imagine beings capable of living in space, traveling between star systems as easily as we travel between continents. For them, the cosmic collision wouldn't be something to survive. It would be something to explore, to study, to participate in. The most incredible part of Earth's journey through the galactic collision is that it perfectly illustrates one of the universe's most beautiful principles: scale independence. On the galactic scale, everything is drama and transformation. Black holes merging, star formation exploding, entire civilizations of stars being reshuffled. But on the planetary scale, on the scale of individual worlds and the life they harbor, the universe provides protection and continuity. It's as if the cosmos has different rules for different sizes. Galaxies collide and merge in spectacular fashion, but planets and their inhabitants are preserved and protected, allowed to continue their own smaller dramas and discoveries while the universe reshapes itself around them. Earth's incredible journey through the galactic collision isn't a story of survival against impossible odds. It's a story of the universe's capacity to create change and preserve continuity simultaneously, to write epic tales on cosmic scales while protecting the intimate stories of individual worlds and the life they shelter. And that journey isn't something that might happen in the far future. In a sense, it's already begun. Every star in our galaxy, including our Sun, is already feeling the first gravitational whispers of Andromeda's approach. We're already participants in this cosmic dance, already part of the greatest story the universe has to tell. The story of how we discovered our cosmic fate reads like the greatest detective novel ever written, except the mystery spans the entire universe, and the clues are written in starlight. It's a tale of brilliant minds, revolutionary technology, and discoveries so shocking that they changed our understanding of everything. Let me take you back to 1912. Picture this: Vesto. Slipher, a quiet astronomer working at the Lowell Observatory in Arizona, is about to make a discovery that will send shockwaves through the scientific world. He's pointing the observatory's 24-inch telescope at something called the Andromeda Nebula, BT9, because back then, nobody knew what it actually was. Now, Slipher is using a spectroscope, a device that splits light into its component colors, like a prism creating a rainbow. But these aren't just pretty colors, they're cosmic fingerprints. Every element in the universe absorbs and emits light at specific wavelengths, creating dark or bright lines in the spectrum. By studying these lines, astronomers can figure out what stars and nebulae are made of, how hot they are, and in 5, most importantly for our story, how fast they're moving. Here's what Slipher discovered, and I want you to understand just how shocking this was at the time. Almost every nebula he observed showed what's called redshift. The spectral lines were shifted toward the red end of the spectrum, indicating that these objects were moving away from us. The universe seemed to be expanding, with almost everything rushing away from the Milky Way. But Andromeda was different. Its light was blue-shifted. The spectral lines were shifted toward the blue end, meaning this object, whatever it was coming toward us at the terrifying speed of 200 miles per second. That's nearly 720,000 miles per hour, fast enough to circle the Earth in just 37 minutes. Now, imagine the shock of this discovery. Here's this mysterious object in space, racing toward us at speeds that boggle the mind. But at the time, nobody knew what this meant, because nobody knew what Andromeda actually was. Was it a gas cloud within our own galaxy? Was it something else entirely? The debate that followed would divide astronomy for over a decade. This was the era of what historians call the Great Debate, and it's one of the most fascinating scientific controversies in history. On one side, you had Harlow Shapley, a brilliant astronomer who had already revolutionized our understanding of the Milky Way's size and structure. Shapley argued that these nebulae were gas clouds within our galaxy. To him, the Milky Way was the entire universe, and everything we could see was part of our cosmic home. On the other side stood Heber Curtis, equally brilliant, equally convinced of his position. Curtis insisted that these nebulae were island universes, entire galaxies like our own, scattered throughout a cosmos far vaster than anyone had imagined. The implications were staggering. If Curtis was right, the universe contained not just billions of stars, but billions of galaxies, each containing billions of stars. The debate raged on through the early 1920s. Public lectures drew standing room-only crowds. Scientific papers flew back and forth like artillery in an intellectual war. The future of astronomy, Hussey, and our understanding of our place in the cosmos, Hussey, hung in the balance. Then, in 1925, everything changed. Edwin Hubble, working with the new 100-inch Hooker telescope at Mount Wilson Observatory, SPA, at the time, the largest telescope in the world, NOS, made observations that settled the debate once and for all. Hubble managed to identify individual stars in the Andromeda Nebula, not just any stars, but Cepheid variable stars, cosmic lighthouses that brighten and dim in regular cycles. Here's what made Cepheids so special. Astronomers had discovered that these stars' brightness cycles were directly related to their actual luminosity. By measuring how bright a Cepheid appeared and comparing it to how bright it actually was, you could calculate exactly how far away it was. When Hubble did the math, the results were revolutionary. Andromeda wasn't a nearby gas cloud at all. It was located nearly 1 million light-years away, far beyond the boundaries of our own galaxy. Curtis had been right. Andromeda was indeed an island universe, a separate galaxy containing hundreds of billions of stars. But knowing that Andromeda was a galaxy racing toward us was just the beginning of the mystery. The real detective work, figuring out whether we were actually going to collide, took decades of painstaking observations and calculations that would make a quantum physicist's head spin. You see, measuring how fast Andromeda is approaching us is relatively straightforward. That's what Slipher had done back in 1912. But collision prediction requires something much more difficult, measuring the galaxy's sideways motion across the sky. Imagine trying to figure out if a distant airplane is going to hit your house. It's easy to see if it's getting closer or farther away, but incredibly difficult to measure whether it's moving left or right. For galaxies, this sideways motion is called proper motion, and measuring it requires tracking the positions of objects across years or even decades to detect tiny changes in their location against the background of even more distant objects. For something as far away as Andromeda, these changes are so small that they're at the very limit of what telescopes can measure. Throughout the 20th century, astronomers made heroic efforts to measure Andromeda's proper motion. They used photographic plates, comparing star positions across decades. They employed increasingly sophisticated mathematical techniques to account for the Earth's motion, the Sun's motion, and the galaxy's rotation. Each measurement was like trying to measure the width of a human hair from a mile away. The early results were frustrating and contradictory. Some studies suggested Andromeda was indeed aimed directly at us. Others indicated it might miss us entirely, passing by harmlessly like a cosmic near-miss. The uncertainty was maddening. We knew this trillion-star galaxy was approaching at incredible speed, but we couldn't tell whether we were in its path. The breakthrough came in 2012, thanks to the Hubble Space Telescope's incredible precision. A team of astronomers led by Roland van der Marel spent years tracking the positions of stars in Andromeda with unprecedented accuracy. Free from the blurring effects of Earth's atmosphere, Hubble could measure tiny positional changes that ground-based telescopes simply couldn't detect. The results were definitive. Andromeda wasn't just moving toward us, it was aimed directly at us. The cosmic collision was inevitable. After a century of uncertainty, we finally knew our cosmic fate. But here's what I find most remarkable about this discovery. We didn't just figure out that galaxies could collide. We learned that galactic collisions are happening all around us, right now, throughout the universe. With powerful telescopes, astronomers began finding collision after collision, each one showing us different stages of the cosmic dance we're destined to join. Take the Antennae galaxies, 65 million light-years away. These two spirals are caught about 200 million years into their collision. Their gravitational interaction, creating spectacular tidal tails that stretch across 600,000 light-years of space. Looking at them is like seeing our own future written in starlight. Then there are the Mice galaxies, showing what happens after the first close pass. Long streams of stars have been pulled from each galaxy like cosmic taffy, creating structures so beautiful they look like abstract art painted across the cosmos. Most spectacular of all is Stephan's quintet, where 4 galaxies are locked in a gravitational dance so complex that it defies imagination. Stars and gas are being exchanged between galaxies. New star formation is exploding across the entire system, and the result is a cosmic light show that demonstrates the creative power of galactic collisions. Each of these cosmic car crashes shows us a different chapter in our own story. They're like snapshots from a photo album of our future, showing us what to expect as the Milky Way and Andromeda draw closer together. But the detective story doesn't end with discovering that collisions happen. Modern astronomy has revealed the deeper mystery. Why do galaxies collide at all? The answer takes us to the very foundations of how the universe is structured. It turns out that galaxies aren't randomly scattered through space. They're organized into groups and clusters, held together by the gravitational pull of dark matter, Li, that mysterious substance that makes up 85% of all matter in the universe. Our local group contains over 80 galaxies, but it's dominated by just 3, the Milky Way, Andromeda, and the smaller Triangulum galaxy. In the early universe, these galaxies were much farther apart, but gravity never sleeps. Over billions of years, the invisible dark matter halos surrounding each galaxy have been pulling them together. What we're witnessing isn't a random cosmic accident. It's the inevitable result of fundamental forces that have been operating since the universe began. And here's something that will blow your mind. The collision with Andromeda is just the beginning. Computer simulations show that eventually, our entire local group will merge into one massive elliptical galaxy. Triangulum will join the dance, along with dozens of smaller galaxies. What starts as a collision between 2 galaxies will end as a cosmic feeding frenzy, creating a single giant galaxy that astronomers have already nicknamed Milky. The detective story of cosmic collisions has taught us something profound about the universe. It's not static. It's not unchanging. The cosmos is dynamic, evolving, constantly reshaping itself through gravity's patient work. The galaxies we see today are just temporary arrangements of stars and gas, destined to merge and transform over cosmic time. And we figured all this out by following clues written in light that has travelled for millions and billions of years to reach us. Every photon that enters our telescopes carries information about the universe's past, present, and future. By learning to read these cosmic messages, we've solved one of the greatest mysteries in astronomy, the fate of our galactic home. The story of discovering our cosmic destiny shows us something beautiful about human nature. Our irrepressible curiosity, our determination to understand our place in the universe, our ability to solve mysteries on the grandest scales imaginable. From Slipher's first observations of Andromeda's approach to Hubble's definitive measurements of its trajectory, generations of astronomers have worked together to uncover the most spectacular story ever told. And that story isn't ending, it's just beginning. Every year, new observations refine our understanding of how galactic collisions work. Every computer simulation reveals new details about what we can expect. Every discovery brings us closer to understanding not just our own cosmic fate, but the fate of every galaxy in the universe. We've become cosmic detectives, using starlight as evidence and gravity as our guide, solving mysteries that span billions of years and trillions of miles. And the case we've cracked, the inevitable collision between the Milky Way and Andromeda, turns out to be not a cosmic catastrophe, but the next chapter in the universe's ongoing story of creation and transformation. Here's something that's going to completely change how you think about cosmic collisions. They destroy nothing and create everything. I know that sounds impossible, but stay with me as we explore one of the universe's most beautiful paradoxes. When the Milky Way and Andromeda finally merge, not a single star needs to collide. Think about that for a moment. Two galaxies, each containing hundreds of billions of stars, pass through each other over millions of years, and the chance of any two stars actually hitting each other is essentially zero, yet both galaxies cease to exist as they were. In their place rises something grander, an elliptical galaxy that astronomers have already named Milky. This transformation from spiral to elliptical represents one of the universe's most fundamental processes, and it's being repeated billions of times across cosmic history. Right now, at this very moment, we can point our telescopes at distant corners of the universe and watch this same drama playing out on stages separated by billions of light years. But here's where it gets really fascinating. While individual stars glide past each other untouched, something very different happens to the gas that fills the space between them. Unlike stars, gas clouds cannot avoid collision. When massive hydrogen clouds slam together at hundreds of miles per second, they don't just bounce off each other. They compress, they heat up, and they trigger the universe's most productive process: star formation. Picture this. A typical spiral galaxy like our Milky Way forms about one new star per year. That might not sound like much, but remember, we're talking about nuclear furnaces, each one massive enough to shine for millions or billions of years. One star per year, across billions of years, adds up to the 400 billion stars we see in our galaxy today. But during a galactic collision, that sedate rate of star formation explodes. We're talking about hundreds of new stars being born annually. The merging galaxies blaze with stellar nurseries scattered across hundreds of thousands of light years. Each nursery is like a cosmic factory, taking the raw materials of hydrogen and helium and forging them into new suns. These aren't just any stars either. The violent compression of gas during collisions tends to create more massive stars than usual, and massive stars are cosmic game changers. They burn hotter and brighter than stars like our Sun, blazing brilliant blue across the spectrum. A single massive star can outshine our entire solar system by factors of millions. But here's what makes them truly special. These stellar giants live fast and die young. While our sun will burn steadily for about 10 billion years, a star 20 times more massive might last only 10 million years. That's 1,000th the lifespan. But in their brief cosmic youth, they accomplish something extraordinary. When these massive stars reach the end of their lives, they don't fade away quietly like our sun will. They explode as supernovas, stellar detonations so powerful they can briefly outshine entire galaxies. And here's the beautiful part. Each supernova is like a cosmic seed pod, enriching the surrounding space with heavy elements. You see, inside the cores of these massive stars, nuclear fusion has been working overtime, building heavier and heavier elements. Carbon from fusing helium, oxygen from fusing carbon, silicon, sulfur, iron, all the way up the periodic table. When the star explodes, it scatters these elements across thousands of light years of space, mixing them into the cosmic medium like ingredients in a vast stellar soup. This is where the creative power of galactic collisions becomes truly mind-blowing. The collision acts like a cosmic mixing bowl, stirring these enriched materials throughout the merged galaxy. Regions that never could have formed rocky planets because they lacked heavy elements suddenly receive a cosmic care package containing all the building blocks of worlds like Earth. Think about what this means. Before the collision, vast regions of both galaxies might have been stellar deserts, areas filled with hydrogen and helium, but lacking the carbon, oxygen, silicon, and iron necessary for rocky planets. After the collision, these same regions become fertile cosmic soil, capable of growing new solar systems complete with Earth-like worlds. But the creative destruction doesn't stop there. The supermassive black holes at each galaxy's center play their own dramatic role in this cosmic transformation. As they spiral together over millions of years, these gravitational monsters create some of the most extreme physics in the universe. Picture this. Our Milky Way's central black hole, weighing in at about 4 million solar masses, locked in a death spiral with Andromeda's 100 million solar mass giant. As they orbit each other, they gravitationally slingshot nearby stars into incredible trajectories. Some stars achieve velocities of up to 1,000 miles per second, becoming what astronomers call hypervelocity stars. These stellar refugees get ejected from the galaxy entirely, carrying with them any planets or moons they might have. Imagine entire solar systems, complete with potentially habitable worlds, being flung into the intergalactic void at speeds that would carry them from Earth to the Moon in just 4 hours. These wandering systems become cosmic seeds, potentially carrying life between galaxies across the vast emptiness of space. But the black holes don't just throw stars around randomly. They also regulate star formation through what astronomers call cosmic feedback. As material falls into these gravitational giants, it heats up to millions of degrees and generates powerful jets of particles and radiation. These jets can shut down star formation in some regions while triggering it in others, sculpting the new galaxy's structure like cosmic gardeners. Recent discoveries have revealed even more layers to this creative process. When galaxies collide, they don't just exchange matter, they exchange magnetic fields. These cosmic magnetic structures, stretching across hundreds of thousands of light years, guide cosmic rays and shape how gas flows through the merged galaxy. They create vast magnetic highways that influence where new stars form and how they evolve. The colliding galaxies also trade globular clusters, ancient collections of stars that preserve chemical signatures from the early universe. It's like cosmic archaeology, with each galaxy contributing its historical artifacts to the merged system. Future astronomers in Milky will be able to trace the origins of these clusters, reading the story of 2 separate galactic histories written in starlight. And here's something that sounds like science fiction but follows directly from physics. Some planetary systems, when flung into intergalactic space, might actually preserve life better than those that remain in the galaxy. Think about it. In the dark between galaxies, there are no nearby supernovas to irradiate planets, no gravitational disturbances from passing stars, no cosmic catastrophes of any kind. A planet with a thick atmosphere or subsurface ocean, orbiting a long-lived star like our Sun, could maintain habitable conditions for billions of years in the intergalactic void. These wandering worlds might become cosmic lifeboats, preserving life and even civilization across the vast ages between galactic encounters. The collision creates new possibilities for life in other ways too. All those massive stars born during the merger don't just enrich space with heavy elements when they explode, they also create neutron stars and stellar mass black holes. These exotic objects generate intense magnetic fields and gravitational effects that could drive entirely new forms of energy generation for advanced civilizations. But perhaps the most beautiful aspect of this creative destruction is how it demonstrates the universe's fundamental principle. Nothing is ever truly lost. Everything is transformed. The spiral galaxies we know and love don't disappear. They become part of something larger and more complex. Every star, every planet, every atom that existed in the Milky Way and Andromeda will still exist in Milkomeda, just arranged in new patterns, participating in new stories. It's like watching two orchestras merge into a single, grander symphony. The individual musicians, A, B, the stars, keep playing their parts, but now they're part of a larger composition, one that includes themes and movements that neither orchestra could have played alone. The elliptical galaxy that emerges from this cosmic collision will be fundamentally different from its spiral parents. Instead of elegant pinwheel arms and organized disk structure, Milkomeda will be a roughly spherical collection of stars in complex, chaotic orbits. But chaotic doesn't mean random. These orbits will be the result of billions of years of gravitational interactions, creating a structure as beautiful and organized as any spiral, just in ways we're only beginning to understand. And throughout this entire process, the universe demonstrates its most remarkable quality, the ability to create order from apparent chaos, beauty from destruction, new possibilities from the ashes of the old. The collision between the Milky Way and Andromeda isn't the end of two galaxies. It's the birth of something entirely new, something that contains all the potential of its parents, plus billions of new possibilities that could never have existed before. This is how the universe builds itself. Tenye, not through careful planning or intelligent design, but through the patient work of physical forces operating over cosmic time. Gravity pulls things together, fusion lights them up, supernovas scatter the products, and magnetic fields guide the flow of matter and energy. It's a process that's been repeated countless times across cosmic history, and it's how every large galaxy in the universe formed. The creative destruction of galactic collisions represents evolution on the grandest scale imaginable. Just as life on Earth evolves through variation and selection, galaxies evolve through collision and merger. Each collision tests new combinations, tries new arrangements, explores new possibilities. The universe is conducting a vast experiment in organization, structure, with each galaxy serving as both laboratory and result. And we're not just observers of this process, M says, we're products of it. The Milky Way itself formed through countless ancient mergers, each one contributing stars, gas, heavy elements, and gravitational structure to our cosmic home. The calcium in our bones, the iron in our blood, the oxygen we breathe, all of it was forged in stellar cores and distributed through galactic collisions that occurred billions of years before Earth formed. We are literally made from the creative destruction of cosmic collisions, standing on a planet formed from the debris of ancient stellar explosions, looking up at a sky that tells the ongoing story of how the universe builds itself through the patient, beautiful work of gravity, fusion, and time. Imagine if cosmic dawn broke today, and humanity suddenly realized that Andromeda had begun its approach. Not in 4 billion years, but right now. Picture the greatest project in human history beginning. Not a project born of panic or desperation, but one of incredible opportunity spanning geological time. With millions of years to prepare, each human generation would contribute to a response so ambitious, so dazzling in its scope, that it would make our greatest achievements look like finger paintings. Let me walk you through what this million-year project might look like, because it's not just about survival, it's about transformation. The collision wouldn't represent humanity's end, but rather its ultimate evolutionary pressure, the cosmic challenge that finally forces our species to become truly galactic citizens. The first millennium would focus entirely on understanding what we're dealing with. Within decades of realizing the collision had begun, a fleet of space telescopes would be launched, not just one or two, but hundreds of them, positioned throughout the solar system and beyond. Each one would have a specific mission, mapping every star in Andromeda, cataloging every gas cloud, identifying every planetary system in our incoming neighbor. Think about the scale of this observational campaign. We're talking about monitoring a galaxy containing 1 trillion stars, each one potentially hosting planets, maybe even life. Advanced gravitational wave detectors would trace the invisible dark matter interactions beginning at the galaxy's edges. Particle physics experiments would probe the fundamental nature of dark matter itself, because understanding exactly how these invisible halos interact becomes crucial for predicting the collision's precise progression. Each decade would refine our models, turning cosmic uncertainty into precise prediction. Computer simulations running on quantum processors would track the motion of individual star systems, predicting which regions of space would become safe harbors and which would become cosmic storm zones. By the end of the first 1,000 years, humanity would know the collision's choreography better than we currently know the orbit of the Moon. But observation is just the beginning. By year 10,000, as Andromeda grows visibly larger in Earth's sky, humanity might be ready for its first truly audacious move, launching intergalactic probes. And I'm not talking about the kind of spacecraft we build today. These would be missions that use the collision itself as a cosmic highway. Picture this: gravitational assist maneuvers, but instead of slingshotting around planets or stars, these spacecraft would surf the tidal waves of distorted spacetime created by the merging galaxies. Using these gravitational currents, probes could achieve velocities impossible in a static galaxy, 2 speeds, that would normally require exotic physics or impossibly large amounts of fuel. Some of these robotic explorers would target the most promising star systems in Andromeda, arriving millions of years before the bulk of the collision. They'd serve as advanced scouts, studying potential new homes for Andromeda, humanity, identifying resources, maybe even terraforming worlds or building infrastructure for the waves of human expansion that might follow. Other probes would position themselves at gravitational balance points, cosmic oases, where the competing pulls of both galaxies create stable regions of space. These locations would become permanent observatories, giving humanity front-row seats to watch the greatest show in the universe unfold over millions of years. By year 100,000, as the night sky begins its spectacular transformation, possibilities emerge that sound like science fiction, yet follow inevitably from physics. If humanity masters controlled fusion, and over 100,000 years, that seems not just possible but inevitable, then the collision's compressed gas clouds become cosmic fuel depots. Imagine fleets of robotic harvesters mining these clouds, each one collecting enough hydrogen to power entire civilizations. The stirred-up cosmic medium, rich with heavy elements from billions of years of stellar evolution, offers unprecedented resources. Elements that are rare on Earth, become abundant in the cosmic mixing zones created by the collision. This abundance enables engineering projects that dwarf anything we can imagine today. We're talking about stellar engines, AZ massive structures that can actually move entire star systems by harnessing their energy output, gravitational mirrors that focus starlight across light years, creating communication networks spanning entire galaxies, defensive screens protecting inhabited systems from the radiation surges that occur during periods of intense star formation. But here's what I find most fascinating about this timeline. It perfectly matches human evolution itself. Over hundreds of thousands of years, our species might undergo changes as dramatic as the cosmic collision happening around us. And I don't just mean technological evolution, I mean biological, cultural, maybe even spiritual. Transformation on scales we can barely comprehend. Different populations of humans might adapt to different cosmic environments. Some could engineer themselves for life in the dark between galaxies, developing enhanced radiation resistance and the ability to survive on minimal resources during the long journeys between star systems. Others might modify their biology for the radiation-rich environments near active star-forming regions, thriving in cosmic conditions that would be lethal to us today. The collision's timescale doesn't threaten human extinction, EVAT. It offers evolutionary diversification on a cosmic scale. By the time Milky fully forms, humanity might mean 1,000 different species, each one adapted to their particular niche in the new galaxy, yet all united by their common origin on a small blue planet that once orbited a yellow star in the spiral arm of a galaxy that no longer exists. Think about what this means for human culture and identity. For millions of years, generations would grow up knowing they're part of the greatest project ever undertaken. Children would learn about the collision not as a distant threat, but as the defining challenge and opportunity of their species. Art, literature, music, philosophy, fear, all of human creativity would be shaped by this cosmic context. Imagine the religions that might emerge, the mythologies that would develop around humanity's role in the galactic merger. Some might see the collision as a cosmic test, others as a divine gift offering unlimited expansion and exploration. The collision would become the central organizing principle of human civilization, the cosmic mission that gives meaning and purpose to countless generations. The psychological effects alone would be transformative. No human generation would ever again suffer from the existential crisis of wondering what their purpose is. Everyone would know they're part of something magnificent, contributors to a project that spans geological time and cosmic distances. The collision would cure humanity of its cosmic loneliness by giving us the ultimate shared goal. But the project wouldn't just change humanity, it would change what humanity is capable of becoming. The collision's energy sources and material abundance would enable technologies that sound magical today. Imagine civilizations that can manipulate matter at the atomic level, rearranging elements as easily as we rearrange words on a page. Space-time engineering that allows faster-than-light communication and maybe even travel. Consciousness uploading that lets human minds explore the galaxy in forms we can't even conceive. By year 500,000, as the galaxies begin their first close approach, humanity might have developed what we could call cosmic intelligence, II, the ability to think and plan on galactic scales. Human minds, whether biological or artificial, could process information about trillions of star systems simultaneously, coordinating activities across light years of space in real time. The most ambitious minds might even attempt to influence the collision itself. Not to stop it, that would be impossible and ultimately undesirable, but to guide it, to ensure that the merger creates the most favorable conditions for life and civilization. Imagine subtly adjusting the orbits of key star systems, steering gas clouds toward regions where they'll trigger the most productive star formation, even influencing the final merger of the central black holes to minimize disruption to inhabited worlds. This isn't science fantasy, it's applied cosmic engineering, the logical extension of humanity's growing technological capabilities over evolutionary timescales. If we can learn to manipulate genetics, split atoms, and land on other planets in just a few centuries, what might we accomplish given hundreds of millennia? The million-year project would represent more than just humanity's response to a cosmic collision. It would be our species' graduation from planetary to galactic citizenship. The collision doesn't just threaten to change our cosmic neighborhood, ICEL, it offers to expand our definition of home from one world to an entire galaxy, from one star system to 1,000,000,000,000 stellar communities. And here's the beautiful paradox. By the time the project reaches its culmination, by the time Milky has fully formed and humanity has spread throughout the merged galaxy, our descendants might look back at this moment, at us, worrying about a collision billions of years in the future, with the same fond nostalgia we feel when we think about our ancestors huddled around fires, wondering what lay beyond the horizon. The collision that we imagine as a cosmic catastrophe might be remembered by our descendants as the greatest gift ever given to our species, the challenge that forced us to become something magnificent, something worthy of the cosmic stage on which we live our brief, brilliant lives. The million-year project wouldn't just be about surviving the collision between the Milky Way and Andromeda. It would be about humanity finally living up to its cosmic potential, finally becoming the galactic civilization we were always capable of being, finally taking our place as conscious participants in the universe's ongoing story of creation and transformation. Now, I want you to step back with me and see the truly mind-blowing picture. Zoom out from our local cosmic drama, from the Milky Way and Andromeda racing toward their inevitable dance, and what you discover is that galactic collisions aren't rare cosmic accidents. They're the universe's fundamental creative process. Right now, at this very moment, over 100 galactic collisions are occurring across the observable universe. Each one follows the same physical laws we've been exploring, yet each creates something unique and beautiful. Think about that for a second. While we've been focusing on our own cosmic destiny, similar stories are playing out on stages scattered across billions of light years. There's a galaxy cluster in the constellation Fornax, where dozens of galaxies are locked in a gravitational ballet that's been dancing for hundreds of millions of years. In the distant Coma cluster, massive elliptical galaxies are cannibalizing their smaller neighbors, growing ever larger through cosmic consumption. The universe builds itself through these mergers, crafting ever larger structures in a hierarchy of creation that stretches from our solar system all the way up to the largest structures in the cosmos. And this process won't end for trillions of years. We're witnessing just one movement in a symphony so vast that human language barely has words for its scope. But here's what's truly remarkable. Our collision with Andromeda is merely the opening chapter in our local story. Beyond Andromeda, the entire local group, 14-9, over 80 galaxies, including the beautiful Triangulum galaxy, will eventually merge into one massive elliptical. This process spans tens of billions of years, creating one of the universe's basic building blocks through patient gravitational work. Picture this cosmic family reunion. First, the Milky Way and Andromeda merge to form Milky. Then, over the following billions of years, Triangulum joins the dance, along with dozens of smaller galaxies, the Large and Small Magellanic Clouds, the Sagittarius Dwarf, the Canis Major Dwarf, and scores of others whose names read like poetry written in starlight. Each merger adds new chapters to the story. The Magellanic Clouds, already being slowly torn apart by our galaxy's gravity, will contribute their unique populations of young, hot stars. Triangulum will bring its own spiral structure and star-forming regions. The dwarf galaxies will add their ancient stellar populations, some of which formed when the universe was less than 1 billion years old. By the time this local consolidation is complete, what started as 80 separate island universes will have become one massive elliptical galaxy, containing the history, the matter, and the potential of them all. It's cosmic evolution in action, the universe organizing itself into larger and more complex structures through the simple, patient work of gravity. But the story doesn't end there. These merged galaxy groups don't remain isolated forever. They're part of an even grander structure, galaxy clusters containing hundreds or thousands of individual galaxies, all bound together by gravity and dark matter into cosmic cities that span millions of light years. The Virgo cluster, containing over 1,000 galaxies, is pulling our local group toward it even now. In 1 trillion years or so, assuming dark energy doesn't accelerate cosmic expansion too dramatically, our merged local group will join this cosmic metropolis. Imagine the night sky of a world orbiting a star in that future megacluster. Thousands of galaxies scattered across the darkness, like glittering jewels, each one a former island universe now part of a vast cosmic community. And even that's not the end of the story. Galaxy clusters themselves can collide and merge, creating structures so massive that they defy imagination. The Bullet cluster, about 4 billion light-years away, shows us what happens when two galaxy clusters slam into each other at speeds of millions of miles per hour. The collision is so violent that it actually separates the normal matter from the dark matter, creating cosmic shock waves that stretch across millions of light-years. Galactic collisions never truly end, they simply occur at ever grander scales, building the universe's structure piece by piece, merger by merger, across cosmic time that makes the age of our solar system look like an instant. But here's the deepest, most beautiful revelation of all. We exist because of ancient collisions. Every atom in your body, every molecule of air you breathe, every element that makes life possible, all of it was forged in stellar cores and distributed through galactic collisions that occurred billions of years before Earth formed. The Milky Way itself is the product of countless ancient mergers. Our galaxy's stellar halo, that faint, roughly spherical distribution of old stars that surrounds the galactic disk, is filled with the debris of smaller galaxies that were consumed long ago. Each stream of stars in that halo tells the story of a cosmic collision, a smaller galaxy that was torn apart and absorbed into our own. The thick disk of our galaxy, which contains some of our oldest stars, likely formed during a major merger event about 10 billion years ago. The thin disk, where our Sun lives, represents the galaxy's more recent, peaceful period of growth. Even our central supermassive black hole probably grew to its current size by merging with the black holes of infalling galaxies. We are literally made from cosmic collisions. The calcium in our bones was forged in the core of a massive star that exploded as a supernova, scattering its contents through a galactic collision that mixed it into the gas cloud that eventually formed our solar system. The iron in our blood was created in similar stellar explosions and distributed through similar cosmic mergers. The oxygen we breathe, the carbon that forms the backbone of every molecule in our bodies, all of it has a history written in cosmic collisions, and this process continues today. As you sit there listening to this story, the universe is conducting countless experiments in galactic architecture. Each collision tests new combinations, tries new arrangements, explores new possibilities for how matter and energy can organize themselves into structures capable of supporting complexity, life, and consciousness. In the Antennae galaxies, 65 million light-years away, we can watch this process happening in real time. Two spiral galaxies are caught in the middle of their cosmic dance, their tidal tails stretching across 600,000 light-years of space. New stars are being born at a rate 100 times faster than normal, creating stellar nurseries that glow with the light of cosmic creation. The Stephan's Quintet shows us what happens when multiple galaxies dance together simultaneously. 4 galaxies locked in a gravitational ballet so complex that it defies simple description, exchanging stars and gas, triggering bursts of star formation, creating structures that exist nowhere else in the universe. Each of these cosmic laboratories is teaching us something new about how the universe builds itself. They're showing us that destruction and creation are not opposite processes, but different aspects of the same fundamental transformation. Every galactic collision simultaneously ends old stories and begins new ones, destroys old structures and creates new possibilities. The universe, we're discovering, is not a collection of static objects scattered through empty space. It's a dynamic, evolving system that builds itself through collision, merger, and transformation. Galaxies are not permanent fixtures, but temporary arrangements of stars and gas, destined to merge and evolve over cosmic time. And consciousness, APA, minds capable of understanding this process, like ours, emerges from this cosmic evolution. We're not separate from the universe looking in. We're the universe becoming aware of itself, developing the capacity to understand its own history and predict its own future. The collision between the Milky Way and Andromeda is part of this never-ending story. It's the next chapter in a tale that began with the first galaxies forming in the infant universe and will continue until the last stars burn out in the far distant future. We're not witnessing the end of anything. We're watching the ongoing process by which the cosmos creates ever greater complexity, beauty, and possibility. In the vast library of cosmic stories, each galaxy is both reader and book, both author and character. The collision approaching us isn't a cosmic catastrophe. It's the universe's way of writing new chapters, creating new possibilities, exploring new arrangements of matter and energy and space and time. As you drift towards sleep tonight, as you contemplate your place in this cosmic story, remember this: the collision isn't coming to us. We're already part of it, products of billions of years of cosmic creativity that shaped the very atoms of our bodies. The dance of galaxies that created us continues around us and within us, writing the ongoing story of how the universe builds itself through collision, transformation, and the endless, patient work of gravity and time. The never-ending story isn't just happening out there among the galaxies. It's happening in every cell of your body, every thought in your mind, every breath you take. You are the universe becoming conscious of itself, the cosmos developing eyes to see its own beauty, ears to hear its own music, minds to understand its own magnificent, never-ending story of creation and transformation. And that story continues tomorrow, and the day after that, and for trillions of years to come, written in starlight across the darkness, told in the dance of galaxies, sung in the collision of cosmic giants that create not destruction, but endless, infinite possibility.